Hello, everyone, and welcome. Today we are doing day 14, inclusive and exclusive events. And so we're going to be able to determine if events are inclusive or exclusive, and we're going to find the probability of both of those events occurring. In our warm-up, we're going to do a little bit of a review with two-way tables. So, first of all, as you can see, it only gives us the total for our columns. So I want us right now to add up our total for our rows. What I mean by that is we're going to find the total number of males and females. So our total number, if you add 40 and 22 and 15, our total is going to be 77 males. And then if you add the 12, 16, and 45 females, you're going to get a total of 73. And then our total people altogether, if we add, you can either add 52, 38, and 60, and that's going to get you 150. Same with if you added 77 and 73. That's how you can check to make sure you got this right. So now that we have that filled in, we're going to find the probability of if we were to select someone at random, if they were male. So remember how that's the total number, the desired number. So number of males over the total, like the total number of outcomes. So our total people, so total is 150. So we have 150 in our denominator, and our numerator is our total number of males, is 77. And so that is equivalent to then, if you take 77 and divide it by 150, you get 50, roughly, well, 0.51 if you round down, or 51%. Number 2 is the complement of finding a male. That's either the same thing as the probability of a female, but remember our trick where you would take 1 minus the probability of male? Since we already know the probability of male, we can take that 100% and subtract the 51% to then get us 49%. So 49% are not male. Now, number 3 says probability of male. And remember this little sign here is and. So probability of male and basketball. So remember for these types with these and type problems, we'll draw arrows until they meet. So we have male and basketball, where they meet is right here. So it's 22. So we'll take that 22 over that 150 total, and that's going to be close. It's going to be about 1.146, which is about, if you round up, it's going to be 15%, or you can say, depending on how you round, you can just say 14.6%. Now we have the male, and what does this stand for? Or. So this is the one that's a little trickier. So remember this one, we have to remember to subtract out our duplicates or our overlap. So we have male male or basketball. So we just had, this was male and basketball. Remember, we're going to have to subtract this out. So, you don't really have to subtract, but just don't count it twice. You don't want to count it twice. So if I count it, if we have 40 for male football players, plus male basketball players, plus male baseball players, then we'll add the number of basketball players total. So if it's male or, so it can be one or the other. So we'll have, again, we're not going to include that 22 again because we already counted it once. So we don't want to double count it. So then we're just left with adding 16 female basketball players. And then when you add that all together, you get 40 plus 22 plus 15 plus 16. It gets you to 93. So we have 93 over 150. So 93 divided by 150 is 0.62. 0.62. And if you move the decimal place over twice, you get 62%. Again, feel free to rewind or pause it whenever you need to. So now I'm going to introduce you guys to inclusive or exclusive versus inclusive. So the stuff written on the left side, the exclusive, actually, no, I'll start with the inclusive. Inclusive is what you guys have been seeing already. Remember our Venn diagrams that look like this with the box around it? That is when both A and B can be true at the same time. So two events that can happen at the same time. And when they do happen at the same time, that's this shaded area in here. So that's where they are both happening at the same time. So when it's inclusive, think it's including it both. So when they're including both of them at the same time, it's inclusive. But exclusive on the left-hand side, the stuff written in blue, is when they cannot happen at the same time. You see how they're not touching like they are over here where they overlap? You can't, it's when there's two separate circles and they're not touching. So the two events that cannot happen at the same time. And we're thinking of, like, this would be, for example, like if you can't be a sophomore and a junior at the same time. You're either a sophomore or B, a junior. You cannot be both. Versus, that's for exclusive. Versus inclusive, so soph, junior. But for this one, you can be, let's see, what's an example here? How we did with that pet example, if you had cats or dogs, so you could say cats, dogs. But you can have both a cat and a dog where they overlap here. You can have both. Versus this one, you can't be both a sophomore and a junior. So the probability of both events occurring down here for exclusive A and B is just, well, this means and again. And it's 0 because they both can't occur at the same time. And then probability of A and B cannot not equal. So A and B, it can't be 0 because there's an overlap. See, if there's overlap, then there's a probability of it happening. Versus if there's no overlap, the probability is 0. So now let's get some practice in. So we're trying to identify whether it's inclusive or exclusive.